Hi there, welcome to your lesson on maximum and minimum points. Big topic in differential calculus, great applied topic, so let's get rolling. First of all, what do we have here? This is some bacteria in petri dishes. So my question to you is, what places in a home have the most bacteria? And here's a list. Here's many common places in the home, and they're all mixed up. What do you think from this list here are the top three most bacteria-filled places in a typical home? Let's check the list. As you can see, things that you would consider very clean, like a dish sponge or kitchen sink or your toothbrush holder, are actually at the top of the list with the most bacteria. And something like the toilet seat, which you might assume is very dirty, well, it's not dirty with bacteria. Let's keep going. So now we have a problem to do with bacteria. So let's say we have this situation. The number of bacteria, B, in thousands, in a culture at time t, minutes, is given by this formula. Okay, so here we have our formula. Again, B produces the number of bacteria and the input is time in minutes. So as you input some minute value in there, this equation will produce the number of bacteria in thousands. All right, so let's say you are asked to find when there are most and least bacteria. So now you can see why in this lesson we're talking about max and min. We're looking for the maximum number of bacteria and the minimum number. The graph of this function, by the way, looks like this. And we can see the number of bacteria grows, then decreases, then grows again. So if somebody said the maximum, you could say right here. For a certain period of time, here's the maximum bacteria, and then later on, there was a minimum here. Okay, so how do we find those? Well, you can go ahead and grab your calculator, and on your calculator, you're going to press the y equals button to enter the equation, then you're going to hit graph, and then we're going to use second and trace to find the max and min points. Let's remind ourselves how to do that. Okay, so here on the calculator, I pressed y equals, and I entered that entire function using x instead of t. Now I'm going to hit graph. Now, look at the graph. I only see part of it going up here, so I know the graph kind of continues off the screen. So I need to change my window, because what I had is my standard graphing window. That means plus 10, minus 10, plus 10, minus 10. I think I had that. Oh no, this looks like more than 10 maybe. No, it looks like 10. Okay, so that's the standard graphing window, but I need to see more. And obviously on this graph I had here, we can clearly see I need to see all the way to 40. But this process sometimes takes some trial and error on your calculator, right? You don't know. So I'm going to go to my window, and I'm going to set my X max something higher. I'm going to say, let's go to 40 on here. I'm going to set my Y max a little bit higher because I want to see a little bit higher. Let's say 20 on here, and then I'm going to hit graph again. Okay, I think I'm going to see more of the graph now. So there it is. Okay, going, there it is. Oh, not bad. And again, I knew the values because I could see them on here. But if you didn't know them, you might have to do the window thing a few times, which is okay. That's part of the process. So here's a graph. Here's a max. Here's a min. I want to find those. So we're going to use second and trace, right? We want to find the maximum bacteria and the minimum. So second calc, which is trace there. And we have maximum minimum here. So I'll start with maximum, number 4. Press that. I need to go to the left of my maximum point. So see the little cursor moving on there? Okay, there I'm going to the left of the maximum point. I'm going to go to the right when it says right bound, because I'm creating boundaries around where I'm looking for the max there. And then it says guess. That means put your cursor kind of where you think the max is. So I'm going to put it somewhere in the middle there. Okay, enter. Great. It calculates my maximum point right there. 9.69 and 17.36 right here. And do the same thing for the min. By doing second calc and then minimum instead. So try that now. What minimum point do you get? Okay, let's double check those points. So there's the max and min we just found. But now let's think of this from a different lens. Let's think of this in terms of calculus. So what are we going to do next? Okay, so again, thinking of this in terms of calculus, we look at our max and min points, which are right here and right here. The points we just found, there's our maximum, there's our minimum. And here's what we know. We know when we're using calculus, we can find the slope of a curve, right? And when we get to the top or bottom of a curve, the tangent line looks like this, or like this, all right? And that means the tangent line shows that there's no slope here, and there's also no slope here. So if we can find the derivative of our original function, and the derivative represents the slope, And then we say, okay, so when is the derivative equal to 0? We can proceed from there. So let's begin by finding the derivative of our function. So apply the basic power rule and find the derivative of that. Okay, so here's our derivative. Check your work on that. We use the power rule. And now we're going to say again, derivative represents slope. And we're saying we want to know when the slope is 0. When? In other words, those 2 points. Okay, again, when is the slope 0? So we're going to take this derivative here that we found and set it equal to 0. We're saying when is the slope, because this function represents the gradient or the slope, when is it 0? Okay, of course you can solve this algebraically, but we can also use our calculator, right? We can graph our derivative function and then check when it is equal to 0. In other words, we can check when the derivative function intersects the x-axis, right? So let's try that now. Let's enter this function in our calculator and find that. Okay, so check it out. I entered the derivative here as my second function, and now I'm going to graph them together. Let's see what we have here. Oh wow, look. Okay, here's the original, and now here's a new graph. This is now the derivative one graphed on there. And we're trying to see when is the derivative equal to 0, right? Because when is the slope 0? And look, when is the derivative 0? It's right here and right here. So let's find those 2 points. Okay, so I had my graph here. Now I'm going to find where the derivative again is equal to 0. So I'm looking for that point. Second, calc, and I want the 0. The x-intercepts are called the zeros, number 2. Okay, it's still on the original curve. The way to jump from one curve to another here, you just got to use the down arrow. It's going to jump to the other curve. There it is. Now it's on this curve. So now left bound, I want to go to the left of the one point I want to find there. Go like that, left, enter. Now it says right bound. I'm going to go to the right of that other 0 or x-intercept. There we go. And now guess. I'm going to move it close to somewhere in the middle there. Great. Enter. All right. Let's check. Ooh, notice we have the exact same value we found before. When we had the original curve and we found the maximum value, it told us x equals 9.69. And again, we have the same thing here. On the derivative is equal to 0 right there. Excellent. Glad to see the same answer. How about you try for the second x-intercept of the derivative, the second 0, and see if it matches what we found earlier. Try it out. Okay, so now, this is an important point. Very important. What did we do? Yes, we did that. Okay, so the important point is this, and let's have both graphs in here. So here's both graphs again. Really key idea for derivatives. We know when we have a curve, and we want to find the maximum point. At the maximum point, there is no slope. Therefore, if you graph the derivative function right here, you will find that that derivative function crosses the x-axis right there. What it's telling us is at a maximum point, there's no slope, therefore the derivative has a value of 0 right here. And also, same thing at a minimum point. At a minimum point, there is no slope, therefore you can see, that should be over a little bit, maybe I can change that. Okay, that means also here where we have the minimum, we can see the derivative has a value of 0 there also because it represents no slope. Key idea in mathematics and in calculus for sure. Let's jump to the next thing here. So let's recap that key idea. Okay, so here we have the maximum point, and we know that point occurred when we had an x value of 9.69. So if you put 9.69 into the derivative of the function, you would get a value of 0, because that's telling us there's a slope of 0 right there. Now, something we're going to learn and check here. Okay, let's say we took an x value before 9.69. So let's say an x value of 5. So because 5 lies to the left or before 9.69. And it could be any value before 9.69. But here's what we're going to do. We're going to put that in our calculator and we're going to check what the derivative value is there. So let's get the calculator here again. And if you remember, we check derivatives like this on the calculator. We can do, again, so I have the graph here. I'm going to do second calc, and I'm going to do number 6, dy dx. That means derivative. So now it's waiting for my input. I'm going to put an x value, like I said, less than 9.69, something that comes before it. Okay, and I said 5 is a good choice. You can choose any number you want less than that. Okay, so there's x equals 5. Enter. It's going to tell me the derivative value. Look, it gave me a derivative value of 1.175 or 1.1575. That means when x equals 5, about here, the slope is 1 point whatever. But here, when we're doing this thing now, we're not concerned about what the value is, but more, is it positive or is it negative? This is a positive value. So what we just found out is when you find out the derivative before this maximum point, we have a positive derivative value. That means it's telling us there's a positive slope here. That makes sense because the graph is rising up. Okay, let's take a value of x after 9.69. So something over here. What's a value after? Well, you can use any value, but I'm going to try 20. Okay, so because 20 comes after that maximum point. I'm going to put that in there again and see what happens. So I'm going to do second calc again, second calc. And this time, okay, derivative number 6. And I'm going to put in now 20. So x equals 20. And now let's check what value it gives us. Oh, it gives us negative 1.08. So at 20, there's a negative 1.088 slope. But again, I'm not worried about the number. I'm looking at the sign. Oh, it's negative. Okay. If this gives us a negative value, then that tells us there must be a negative slope. And if there's a negative slope, that means this is going down. Now, this might seem obvious. We can see that it's rising, it's falling, there's a maximum. But let's say we didn't have the graph. If we didn't have the graph and we had this point and we know maybe it's a maximum, maybe it's a minimum, well, we can double check. Is it max or min? We can check by doing this. We can take values before and after that potential max min point, put them in the derivative, and find out. If it's positive, it means it's rising and falling after. That means it must be a max. But if we go on this side where we have the minimum, and now we take a point after x, okay, I think this one was 31.2 here at the minimum, so the slope there is 0. But now if we go after 31.2, for example 35, put that in the derivative, that would produce a positive value. So again, that tells us this is now increasing. There's a positive slope. So we have confirmed this is a minimum point because we are decreasing and then increasing. The slope is negative and then positive. Therefore, this must be a minimum point. All right, so that's an important idea. It's really a central idea to calculus. Again, if we have a positive slope before and a negative after, we know that point must be a maximum. And if we have a negative slope before and then a positive slope, in other words, negative derivative value and positive, then this must be a minimum. Big idea. With all that information, you're ready to try a couple problems on your own. Try this one. First, we have this curve equation given to us, and it says find ds dt. That means find the derivative of this. So do that. Okay, check your work. By the power rule, you should get this derivative. Next, it says on the same axes, sketch the original function and its derivative. So now you can use your calculator. You can enter both functions, the original and the derivative, and see what they look like on your calculator, and then sketch them on paper, because you often have to do this in the exams. You have to sketch what you see on your calculator, so do that now. All right, let's check our work. So here's the original in green, and here's the derivative in purple. Hopefully your sketch looks like that. On your calculator it says, well, solve the equation ds dt equals 0. So in other words, look at the purple graph and find out when it equals 0, because that's the derivative graph, and it equals 0 here and here. So use your calculator, use second calc and then zeros and find those 2 points exactly. All right, you should have gotten these answers here. Okay, so now, next question. State the feature of the original graph indicated by these 2 points. So you just found these 2 points. What do they have to do with the original graph? Explain that. Okay, as we know, when the derivative is 0, we are actually finding out on the original graph where we have max and min points, because at those points there is no slope, and that's what we found when we found derivative equals 0. So we found the max or min points. That's important. Okay, now so the points we found are these here, the max one and the min one here. And so that we know, these points are called your local max min, because there can be other max min points. Because in the next question it says this: if the domain of the function is restricted to -2 to 2, that means now the x values or inputs can only be -2 to 2. So now we're saying here to here. The function can only exist between here and here. So now, instead of this going down forever and this going up forever, it goes down here and then it ends here. So it has like an endpoint. And on this side, the original graph will also have an endpoint. So those endpoints are now your new max and min points, right? So here's a hint for you. The local max and min points may not be the actual max min points of the whole graph. So now these are called local max min, and we have these now other max min points. So let's find them. How do we find those? What I did, I entered the function, and now I'm going to graph it. So here's the graph, looks like this green one here. And now if you remember, if you want to find some coordinates, you just go to second calc and you say value. Okay, value. And I want to say, okay, at x equals -2, because that's what we set our domain to, -2 to 2. Enter. And it gives me the y value, -6. Repeat the same thing for the other end, x equals 2. Those 2 coordinates we found are called our global max min, and you can see there's one here and 1 somewhere up here. Great. One more. Try this problem here. And now let's check our work carefully. You may want to pause because the video is going to end in a moment and just check everything carefully. Check your work. How did you do?